Over the years, we have implemented a safety program which compares well with those of our industrial peers, both in terms of lost workdays and total incidents. However, accidents continue to happen involving our own employees and third parties. In spite of this comprehensive program, 10 of our colleagues around the world lost their lives in various industrial accidents in 1995 and 1996. In addition, there were over 60 serious incidents. Vigorous efforts have been made and will continue to be made to train everyone at all levels in the company. Yet, a detailed analysis of recent accidents has revealed that in a number of instances, some employees still did not fully appreciate the consequences of not following established work rules and procedures. We all know what can happen if we drive on the wrong side of the road. We therefore obey the established traffic rules. We all know that playing with fire is not safe, so we teach our children the simple rule, don't play with fire. Similarly, our rules and procedures for workplace have been carefully designed to promote safety and protect our employees. We must all understand and follow them, and there can be no exceptions, because the consequences can be a serious accident. One of the keys to improving safety performance is effective communication, which helps to make us all more aware and more informed. The group is totally committed to continuously improving its communications relating to safety. And the video you are now watching, and which I'm sure you will find relevant to your own work environment, is the latest important step. It is the first of a new series, which forms part of the group's worldwide safety program. This time around, the focus is on the hazards most commonly encountered in our gases operations. Subsequent videos will be of greater relevance to other BOC businesses as well. This has not been an easy video to make, nor is it pleasant to watch. But we want every BOC Gases employee to view it, to discuss it, and to take the lessons to heart. Please take the opportunity today, while it is still fresh in your minds, to discuss it as a group and relate its messages to your own work activity. Our message is simple but fundamental. Safety is everybody's business. We can prevent accidents, and we must never compromise on safety. Safety has always been a key imperative for the BOC Group. It must and will remain so.
For the eagle, catching a snake is a hazardous business. It's fast and it's poisonous. One false move and the eagle could be dead. If the eagle is going to stay alive and thrive, it must understand the hazard it faces and never underestimate the risk. Do you understand the hazards you face? Do you know the risks? Are you playing fast and loose with health and safety? A hazard is any situation which could cause damage or injury. This is clearly a hazard. A ramp like this can be a hazard for a cyclist. This stuntman is able to face these hazards and emerge unscathed because he's perfected his skills and reduced the risk to a manageable level. Risk is a combination of two things: the likelihood of a particular accident occurring and the amount of harm that would result if it does occur. If an accident is very likely to happen but won't cause significant injury, it's relatively low risk. If an accident will cause severe injury if it occurs, but it's very unlikely to happen, it's still only a moderate risk. But if an accident is very likely to happen and will cause severe injury when it does, it is high risk. Do you know what hazards exist in your workplace? Have you assessed the risks associated with those hazards? Have you reduced those risks which are unacceptably high? These are the significant hazards covered in this video. The first is fires and explosions. Fire is one of the most important dangers that face us in the gases industry. Its effects in one of our plants can be both widespread and catastrophic. All too often, employees don't realize just how hazardous gases can be. Staff at what was then the CIG plant at Melbourne in Australia were one day confronted with a problem. 200 cylinders they had been filling were found to be over acetone. To remove the excess acetone, they decided to invert the cylinders, allowing them to be blown down to atmosphere. With around 50 inverted, the excess air and acetylene mixture from the cylinders ignited. The fire totally destroyed the plant, and one employee was seriously injured. Asbestos from the cylinders escaped via the fire to the surrounding area. The staff just hadn't realized how big a cloud of highly flammable air and acetylene they were creating. The slightest spark was going to create a disaster. It's vital that you understand just what the products you're handling are capable of, and what damage they can do to you and to the environment. Two of the most common gases we deal with are oxygen and nitrogen. They are the two main constituents of air. We breathe them in all the time, but that doesn't mean they're safe, especially if they're on their own. Air contains about 78% nitrogen, 21% oxygen, and 1% argon. Oxygen is the bit we need to breathe to stay alive. If the other gases in the air are increased, reducing the amount of oxygen, this is called oxygen depletion. If we breathe in oxygen-depleted air, we're likely to lose consciousness. Below 11% oxygen, brain damage and death can occur. Taking just 2 breaths of nitrogen or argon-rich air will cause a sudden loss of consciousness. Oxygen depletion is a substantial hazard and in some situations a high risk. Nitrogen and argon in gaseous form are colorless, odorless and tasteless. So if you breathe in nitrogen or argon-rich air, you won't feel any strange symptoms. You won't notice you're passing out. The inert gases like nitrogen and argon are invisible killers. You must know the danger signs and where these gases might accumulate if they escape. Nitrogen has a tendency to collect in dips, trenches and enclosed spaces. John Porter, a cryo-speed operator, was making a regular delivery of liquid nitrogen to a customer vessel at the Scottish National Blood Transfusion Service. He went downstairs and coupled up to the tank.
I looked at the gauges, and the gauges were all showing empty, no pressure. I came back up the stairs and I opened up the valves on my tank and started filling. I then went into the van and started making out the delivery note for the customer. I had been in there a few minutes, and a chap called Bob McIntosh, one of the drivers, came along and he says to me, "John, that tank's full." And I told him that it couldn't be full because I hadn't filled it. He says, "A tanker came in yesterday and filled it." So I didn't argue with him, I just had a look over and I could see that the pit was starting to fill up with gas. So I then went to the back of my van, switched off the valves, went down the stairs pretty rapid, shut off the valves. I turned, put my hand on the banister, and that was the last thing I knew. I just completely, just blacked out completely. I didn't have any warning or anything. Nothing at all. You don't gasp for breath or anything like that. You just go out.
2 employees saw what happened and ran to help.
We both ran, put in BA sets, checked them over okay, put them on, and we went down. I went down first. I located John at the bottom, on his back. Once I found his head, I pulled him upright, put my arms underneath his arms to lift him, and Alan Butler got his legs. And I couldn't hear any noise from John at all, and I was really quite panicky at this point, wondering if he was dead or not.
And the next thing I knew, I just seen a blue flashing light, and I felt the mask on my face, giving me the oxygen. And they must have been very quick coming down, because if I had been in there more than 3 minutes, I would have been suffocated, I would have been dead. I'm just glad that Jim and Alan were there that day to save my life.
John was very lucky on quite a few points. Lucky that Bob the driver was there, lucky that myself and Alan Butler was there, and very lucky that the PFC have BA sets that are quite handy and are kept up to maximum use.
A new but experienced maintenance fitter at a plant in Middlesbrough in England was not so lucky. He was working on the 720 plant general overhaul, replacing the element on a liquid oxygen filter vessel. On the morning of the accident, he needed to complete work on a broken stud on the top filter cover. Overnight, the nitrogen thaw to the liquid oxygen filter vessel had been started. The next day, the thawing process was stopped and the lines isolated so that maintenance work could continue. The fitter removed the checker plate and worked on the filter cover, releasing residual nitrogen, which flowed out of the filter vessel, reducing the oxygen levels. He was overcome by the warm stream of nitrogen rising vertically, and he slumped forward unconscious. He was found a short time later and quickly pulled back from the open. Colleagues tried mouth-to-mouth resuscitation and used a Minuteman resuscitator together with a heart massage. But there was no sign of life, and he was certified dead on arrival at hospital. Although oxygen is vital for life, enrichment of the atmosphere with oxygen, even by a couple of %, considerably increases the risk of fire. Oxygen as a gas is also colourless, odourless and tasteless. You can't tell it's there from any of your senses. So oxygen enrichment can also be a hidden danger. It can dramatically alter the way a substance burns. We can see in the laboratory that materials ignite more easily, and sparks which would normally be regarded as harmless can cause a fire. The resulting flames are much hotter than normal and spread at much greater speed. A glowing splint placed in oxygen will relight with a vigorous flame, and on the other hand, when placed in nitrogen, the flame is immediately extinguished. Also, when a lighted cigarette is placed near a high concentration of oxygen, the cigarette burns down to the filter within seconds and only ash is left. This could also apply to your clothing or hair, which is why cigarettes and other ignition sources are banned wherever an oxygen-rich atmosphere could possibly occur. At one of our oxygen plants in Canada, workers in the control room were unaware that danger was creeping up on them.
The plant had been down for 2 days for maintenance purposes. We tried to get the plant online, but because we were struggling with high liquid levels, we decided to dump liquid. And we dumped quite a bit of liquid. our dump header configuration was basically a 6-inch pipe sausage cut that would dump out onto the gravel. And during that time, there was quite a fog involved. Jeff Grota and I decided to get the plant back online. We proceeded for the rest of the afternoon. We encountered several problems trying to get this sleeping giant back up on its legs and working.
What they didn't realize was that the dumped oxygen had cracked a pipe carrying cables under the gravel. The oxygen was seeping back into the control room through the electrical conduit.
I came back in to start the startup sequence. And just as I walked in the door, I see Jeff dancing around, his pants are on fire, and he's obviously got problems. At first I thought it was a little bit of a joke because he's jumping around, and I didn't think it was so serious. But as I started to look around the room, it was really, really, really unusual. Things that you wouldn't think were burning, and little things were starting on fire, maybe the top of a pop can, things you wouldn't suspect that were starting on fire. I immediately grab a fire extinguisher, and we douse him down with the fire extinguisher. And the very peculiar thing is the first time that I douse him down, he starts back up again. And the second time I douse him down, wait a second, and then all of a sudden, poof, up he goes again. The third time we got him out, we said, that's enough, we got to get out of here, you know. So we left at the north entrance, collected ourselves in the north part of the building. I went back into the maintenance shop, and I phoned 911, and returned back into the control room. And at that time, I opened up the door, and the black smoke was billowing out. I tried to empty, well, I did empty the fire extinguisher that I had in hand, and it was just out of control at that point. I jumped in my car as fast as I could. I got Jeff to get into the car. I still hadn't seen an ambulance yet, and we drove as fast as possible to the local hospital, which is about 3 blocks away. And they started to treat him right away in triage for his burns and things that had happened to him. Very, very unnerving.
Cold gaseous oxygen is substantially heavier than air and may accumulate in pits, trenches and low ground. This should be taken into account when planning cryogenic installations. If there's liquid spillage or venting which could produce oxygen enrichment or decreased visibility, where will the gas collect? In Manila in the Philippines, oxygen escaping from a tank led to appalling scenes in a street market as a gas cloud rolled downhill. The vessel was being filled with oxygen from the tanker. The driver was tapping the fill coupling with a mallet when the T on the liquid line from the vessel failed. The driver and tanker were enveloped in gas, reducing visibility to almost zero. The full load in the vessel escaped, and a large cloud filled the compound and then moved into the main road. It travelled across the ground towards some market stalls and a jeepney 90 metres away. When the jeepney driver turned on the ignition, a fireball enveloped the area. A jeepney passenger was badly burnt due to oxygen enrichment of his clothes, and the office and tanker were destroyed. Although oxygen itself is not flammable, if the conditions are right, most engineering materials will burn fiercely in oxygen. In this lab demonstration, stainless steel swarf is burning in an oxygen-rich environment. This produces one of the hottest flames known. A biscuit like this will normally be very difficult to ignite, but placed in liquid oxygen, it will burn spectacularly. Most of the materials we use in oxygen systems, pipework, valves and the like, can be ignited in oxygen under some conditions. Wherever possible, we use materials which are difficult to ignite and don't burn strongly if they do catch fire. It's therefore important that all equipment and components are approved for use with oxygen. That wasn't the case at J&L Steel in the USA. James Osborne was delivering liquid oxygen from a trailer.
I walked back up, stood at the far side of the trailer, and looked at the pressure gauge on the trailer to see if my pressure was all right on the trailer. And at that moment, that's when a big red ball of fire came at me from the pump. And it covered the whole side of the trailer. And when it went off, I felt the doors blow by my face, the wide doors on the trailer. That's when I went running to the front of the truck. I stopped by the truck. I noticed it was totally out of control, out of my control. There was nothing I could do with it. I went inside a building here and got the phone and called the fire department and told all the people inside the building to clear the building because I didn't know really what it was going to do.
He was using a ground-mounted pump. The inlet to the pump had been fitted with a stainless steel inlet filter not approved for oxygen service. It should have been a Monol filter. When the filter failed, it was sucked into the inlet of the pump and friction set the pump on fire. No one was injured, but the road tanker and the customer's installation were very badly damaged. Not all poisons need to be swallowed to cause harm. Some poisonous or toxic substances can cause injury or death if they're breathed in or absorbed through the skin. Typical toxic gases used in BOC are hydrogen chloride and electronic gases containing arsine. A fire in one of our plants in North Carolina in the USA, whilst burning off residue from cylinders, caused a leak of phosphine and arsine. Both can be deadly if significant quantities are breathed in.
At the time of the incident, I was hooking up 10 cylinders to dispose. I had opened up 9 of them with no problem. We would burn all 10 at once. When I went to open the 10th cylinder, it just, something blew right there and then. I don't know exactly what it was, but that cylinder blew and my hand was on the cylinder when it blew.
Prompt action by fire officers and BOC staff meant nobody was injured in this particular case, even though the plant was severely damaged. The staff were well aware of the risks of these toxic gases, and everyone within a mile was evacuated from the area. About 30% of all cylinder incidents reported to BOC are the result of internal corrosion. How often and how thoroughly are cylinders in our plants inspected and tested? It was a Tuesday night at Basildon Bowl near London. The place was crowded. Drinks were still passing across the counter when a 10-litre cylinder containing carbon dioxide and nitrogen at a pressure of 180 bar lying on the floor had exploded and split in two. Part of it passed through a door and ricocheted around the room, luckily expending its energy before landing near a woman's staff member. On investigation, it was found that the cylinder had suffered from acidic corrosion, corrosive product backfeeding into it, weakening the walls, which exploded when the cylinder was under pressure. 11,000 cylinders were withdrawn as a result of the accident, and on inspection, 30 were found to be heavily corroded. The acidic corrosion was probably caused by a combination of carbon dioxide and the presence of a sulfur compound, possibly feedback of tonic water syrup from a customer's process, mixing with moisture to form a dilute acid. A hydropneumatic burst test on one of the 30 affected cylinders shows the typical high-energy fragmentation rupture. It could have caused a far worse accident at Basildon Bowl. All BOC gases are held within systems or containers specially designed to hold them safely. It can be disastrous if a gas of the wrong composition or pressure is filled into a cylinder not designed to contain it. To avoid this happening, most gas companies have gas label identification, and operate a system of valve outlets with either incompatible threads or pin index outlet connections so they only accept the correct gas. This creates difficulties where plants serve several markets and companies with differing standards and cylinder designs. Then cylinders with varying outlets of the same product may have to be filled on a common cylinder filling rig using adapters. This is Davao in the southern Philippines. It was here that an acetylene cylinder of European design, privately owned by a customer, found its way into an operation based on US cylinder styles. The cylinder was unlabeled and the basic pre-fill checking for stranger or private cylinders was not carried out. The use of adapters was normal for certain cylinders at the plant. The adapter used to fill some oxygen cylinders also fitted the stranger acetylene cylinder. The stranger cylinder was mistaken for an oxygen cylinder and filled with oxygen to the normal filling pressure.
The customer claimed for his acetylene property cylinders. So I went to BOC Panacan to locate the cylinder. And when I arrived at the platform, I saw the cylinders among the field cylinders. So I immediately called the attention of Mr. Lo Dilator, the operator.
To make sure about the identity of the cylinder, I tried to inspect it around.
And we tried to transfer the cylinder a little bit ahead from the other cylinders. And I saw Dilator sniff the cylinder.
I smell bad odor, then I'm sure that's an acetylene.
We called again the helpers and investigate why do we fill the cylinders when it was an acetylene cylinder. One of the helpers tried to open up the cylinder valve. There was an explosion, and suddenly, simultaneously, there was a falling of cylinders.
I saw Mr. Into, the cylinders had been top of him, and he's standing, he's shouting. He's badly burned, his face, his body, his hands. And he's shouting.
Mr. Alarcon and Mr. Soko already burned. And because I jumped from the site, I jumped to the ground, I only realized that one of us died on the spot. It was Mr. Luis Alangoso, the one who opened up the valve. I never tried to go up, sir. I realized because one of the employees saw that he was already lying down on the cylinders. His body dismembered. I gradually realized the pain in my hands and on my face.
2 workers were killed and 2 others injured. The cylinders were not properly color-coded and adapters should not have been used without proper controls. We deal on a daily basis with potentially dangerous substances. Your safety and that of thousands of others is in your hands. What have you done about safety? Have you identified the hazards on your site? Have you assessed the level of risk of each hazard? Have you introduced controls to reduce the risk of high-risk hazards? Fire is one of the most important dangers we face. Are you on the lookout for any situation that might bring about a fire? Do you understand the properties of the products we produce? You can't tell when oxygen in the air is depleted below 11%. You have only a few minutes to live. You can't tell when the air is enriched with oxygen, but just a couple of percent extra in the air can increase dramatically the chances of a fire and cause unexpected materials to burn. Do you use equipment approved for use with oxygen? Do you have a system for working with stranger cylinders? Do you use adapters? If you have to use them, are there set standards and procedures, and do you have a system in place? Are you checking cylinders regularly? Corrosion can produce a massive explosion when a cylinder is under pressure. Use risk assessment to identify high-risk hazards. Identify potential hazards. Estimate the level of risk. Introduce controls for identified hazards. Communicate and train employees. Monitor compliance. We can never take gases for granted. Are you in control? You need all your wits about you and a thorough knowledge of the dangers you face. Just one lapse in concentration could spell disaster.